works. Okay, so today I want to give a very short lightning talk on AI, which has been very big and it still is. And I want to focus on AI for databases, so how to use it with Postgres. And I also want to talk like what it is, how it works, and also why it matters. So let's start. So Gen AI, or Generative Artificial Intelligence, I'm sure you've heard and you know what it is. So have you heard these terms, LLMs, OpenAI, vector database, RAG, embeddings, agents? So when we think of AI, we think of it as like AI is big also as a field or a domain, and it includes different subdomains in it. And then when we talk about generative AI, which is more about creating new original content, and that content is anything from images to text, using vast corpus of data, and LLMs are trained on huge amounts of data. I think Gen AI actually fits into it's even like narrower, so because it uses huge amounts of data, and it's very also specific in terms of how it works and also what kind of content it generates. And actually, I think you know about ChatGPT, which is the LLM-powered application. There are also other LLMs out there. Some are open source, some are closed source. OpenAI APIs are used to generate different types of content. We use vector databases, which I will speak about a bit later, and also the concept of RAG and embeddings, and agents are more autonomous based on LLMs that based on the concept of RAGs actually. Yeah, let's just move on to retrieval augmented generation, or RAG. So the go-to database for implementing RAG is vector database or vector store. And RAG, actually you could pair it with any database, not just Postgres, but any database. So this is basically high level how it works. So the user prompts the LLM, and the LLM gives a response. But when you have RAG, which is the purpose of it is to help build better AI, and by connecting to some external knowledge source, you have also document store and retrieve documents. So you are basically prompting or doing vector search in a vector database that has stored embeddings, which is the data in numerical form, but not just simple vectors, but more in n-dimensional. It's in n-dimensional vector representation. In that case, you actually use RAG with some kind of database. You can also don't need any database, but when we're talking about some applications where you're basically storing or querying data, and you have lots of data, then you need some kind of database where you have all your documents and you're searching through your document store. Actually, RAG is more vector similarity search, not just keyword searching. And when implementing RAG with vectors, whatever LLM you choose to create the embeddings is also the LLM you use to create the embedding of your questions. So questions are the prompts that the user is prompting the LLM. For example, when you're using the interface of ChatGPT, as a user, you're prompting the LLM to give you some answers, you're giving some questions to it. So when you're implementing RAG with vectors, and vectors, I already mentioned that they are embeddings, also numeric. So whatever LLM you choose to create embeddings is also the same LLM you use to create the embedding of your questions. So how basically the similarity search works is It searches for the semantic meanings, so similarity between the numeric vectors for different kinds of data. For example, also text to see how similar they are. And when you are asking a question about your data given to the LLM, it gives you this embedding, and this embedding more or less is compared with all the data. So this is how similarity search works. So for example, you can see in here that we have the data points wolf and dog. So these words should be close in meaning. So with vectors, we can store them as points in space and measure distance. That's why they are very useful in here. And this also allows the semantic search, finding by meaning, not just exact keywords. So what are embeddings? They are vectors, a way to represent complex things like words or pictures as numbers. So you can see we have complex data and we want some kind of numeric representation. So computers can easily compare and calculate with them. So vector databases are the vector stores where they use this embedding, store these embeddings, and embeddings are generated by the LLMs. An LLM like ChatGPT creates a vector embedding of the data, which is assigned a numerical value to each one of the data points. So why did vectors come into play? They became very popular because the traditional data formats were not enough. So because AI was exploding, we needed new kinds of databases, and databases evolved as well. So we need new kinds of databases that can actually work with embeddings, work with vector data, and relational or SQL databases are not enough for that. We need modern vector databases to build AI applications like recommendations, chatbots, or other. So that's why we use vector databases. So the LLM pipeline with RAG is basically like this, from top to bottom. The user is giving the prompt, for example, what's the latest feature in Postgres 16, and then embed the query. It converts into vector representation, then the RAG happens, so use the embedding to search a vector database, and here are some examples. You've heard of Python, Weaviate, etc. These are very specialized vector databases. This step is done for semantic search, and then the augmentation of the prompt is combining the user query plus the user documents into an enriched prompt so that you have more context in the LLM, and then you have a better AI application. So this is basically how it looks. The embedding model, the vector store, this is the query, we have the documents, and then in the embedding model we have the embeddings. We have them in the vector store or the vector database. So the similarity matching is done, and then the LLM generates an output. So now where does ChatGPT, for example, and Postgres, what happens when they meet each other? So this is what happens. pgvector is the Postgres, the extension for Postgres that makes Postgres function as a vector database. So if you're using Postgres, you can already use pgvector. You're already using Postgres to do all of this without any external infrastructure or databases. pgvector is open source, it's an extension. We know that Postgres is extensible, so this is one of the extensions. It's open source vector similarity search for Postgres. When we want to perform RAG with Postgres, so RAG is basically this LLM plus the external knowledge base. The LLM generates text, but before answering, it retrieves some relevant context from your data, and retrieval is usually based on vector similarity search. So why actually use pgvector if we can just use RAG? Because pgvector enables RAG to work well at scale. Without a vector database, you cannot really do much at scale. And if you want to build applications at scale, you need, of course, not in every case that you need some kind of database. And again, if you're already using Postgres, pgvector can be the best option. So where does it come in? Without something like it, your RAG system is not efficient to store and search embeddings. So RAG is just that framework, but pgvector plus RAG is the infrastructure or the tool that enables you to do that, to have a working system. So you store embeddings, you perform similarity search directly in Postgres, and you keep structured data plus unstructured in one place. So this is actually a lot faster. pgvector is easy to set up and install and use. That's why it's recommended if you're already using Postgres. So again, it allows you to directly implement RAG inside Postgres. No need for extra infrastructure. I also wanted to actually mention that, of course, you not always need to use, like if you're working with, for example, OpenAI APIs, you're building applications, you don't always need a database, but this is specifically if you are already using a database. So, for example, you can see the difference where you have Postgres database, you have the pgvector. So what are the benefits? If your app needs to search across a large collection of documents, again, use pgvector or vector database. If you want fast and relevant retrieval, if you already use Postgres and prefer not to introduce a new database, you can just go with it. I wanted to also reference to my book. This was published in December 2024. I actually was very excited about this advancements in AI, so I decided to author a book on it. And this includes example projects where you're building applications with OpenAI APIs and Next.js without pgvector or database like that, like Postgres. But if you're interested, I think this can give you also some maybe ideas, and you can, of course, integrate pgvector with your applications to build better AI at scale. That's why, if you are interested, I would recommend checking it out. This one on the right is the book, and this one on the left is my blog, where I'm posting more content on this stuff. So I will wait for 1 second if you want to scan. And yeah, let's connect on LinkedIn. I'm always happy to chat about AI and databases. Thank you so much.